Okay, so let's talk about sampling. Here we're going to talk about this as a way to calculate probabilities approximately when you don't have an exact density, perhaps. So you have to imagine that the data that you get in the real world when you do a survey or an experiment or something, that's just a sample from the population. You usually don't have the whole population that you care about. So how do we simulate that in R if you just have a density function? Like, let's say you don't have the population data set, but I want to imagine if I had a random variable, it has a certain density or certain distribution, how do I get like a sample of 100 people from the population data set that that distribution represents? So here we know that if we had the population data set, if I wanted to draw a sample from it, you can do that using the slice sample function. What's the equivalent? If I want to sample from a distribution where I know my variable is normally distributed. So in R, you can do this with the little r functions if you provide the distribution. So little r norm is draw this many people from the normal distribution. The standard normal here, because you haven't said what mu and sigma are. So this is kind of like if I had a population data set where x were normally distributed, and I sampled 1,000 people from it. That's what this is doing, except here I never even have to instantiate the population data set. So that's quite nice. You can see it works. If you run this and you put n to be 10, and then you make a little histogram, you'll see it look something like this. It won't look exactly like this because you're going to get a different sample than I did. But in character, it'll look something like that. N equals 100, n equals 1,000. As you keep increasing the value of n, our two histograms are going to look more and more similar because they're going to approach the population histogram, something that looks like a bell curve. This is often useful because let's say I want to calculate a probability, but I don't have, numerically the explicit density, but I know how to sample from it. I can draw arbitrary numbers of people from this distribution, but I don't maybe have like the exact form, or I don't know how to calculate the area under the curve or something like that. So for example, with the normal distribution, let's say I want the probability that x is between -1 and 2. I know I can do that with the p-norm. I calculate the area under the curve less than 2 minus the area under the curve less than 1. That's the area under the curve between -1 and 2. Great, I got that answer. Let's say I don't want to do that. Well, I can get a very close approximation by just taking a sample, a very, very large sample of people from this distribution. So really it's a sample, but I'm just going to call it approximately the whole population because it's so big, right? The real population is infinite because this is a continuous random variable. So it's infinite, but I'm just going to take a really big finite number. And then all I need to do to estimate this probability is take my approximate population and just count how many times did this thing happen and divide by the total number of rows, which is what I am doing here. And I'm sorry, this is a little bit different than the way I've shown you to do it before, but it does the same thing. And you can see that the answer is very, very similar. So if I took n to be bigger and bigger and bigger, this number would become a closer and closer approximation of this.